Hey everyone, Simba Khadder here, this time on video, and you are listening to the MLOps Weekly podcast. Today I'm speaking with Ketan, who's the CEO and co-founder at Union AI. Previously, he had multiple senior roles at Lyft, Oracle, and Amazon, ranging from cloud, distributed storage, mapping, and machine learning systems. He's passionate about building software that makes engineers' lives easier and provides simplified access to large-scale systems. Besides software, he's a proud father, husband, and enjoys traveling and outdoor activities. Really excited to speak with him today.
Hey, Simba. Nice to be here as well. And thank you for having me.
Obviously a lot we want to talk about today. A lot of people know you from your work with Flyte. I think it'd be great to maybe kick off by having you talk about the creation of Flyte. Why was Flyte created? What was the kind of journey?
Yeah, probably understanding creation of Flyte need a little bit of quick background on me. So my name is Ketan. I'm the CEO and co-founder at Union. I'm an engineer for 20 plus years now, 2 decades. You look back and you're like, man, that's a lot of time. And I've been fortunate to work at like banking, high frequency trading, logistics, mapping, build cloud from ground up, and across multiple different companies, Citadel, Amazon, Oracle, etc. And I ended up at Lyft in about 2016. I was the first few people within the Seattle office. And within that, I ended up starting to lead like a ETA models team, which was responsible to build models. It was an ETA model. It was an ETA prediction team. But we were trying to optimize the number that you see on the Lyft app, which is 3 minutes to get a ride, $25 to your destination. 2 numbers. And many people would ask, is 3 minutes accurate? And the question is, it's accurate for you, right? It's the right number that you should see. But what that means is there is a general way that the number is computed. It's not purely distance-based. It's a bunch of different factors that come into play, like traffic, which side of the road you're standing on, perception, how likely are you to convert, like just all of these things have to go into one number. So we started using machine learning to solve many of these problems and improve conversion and other metrics. This was probably in the modern sense, this was my first tryst with machine learning. While I was at high frequency trading and so on, I was doing some quant stuff and I did have some machine learning work, but I was not really involved. And when I was at Amazon doing logistics, we used to do operations optimizations, for example, traveling salesperson or graph routing algorithms or include routing. We didn't call it machine learning, it was just software. But in this case, it was purely, there was a bunch of researchers and data scientists and software engineers all working together. And we were trying to deliver models. That's what led us to, and in 2016, we were just doing whatever random stuff that came our way. Like people are going to build their models on their laptops, deploy them, and if that person leaves, the model is lost with them, we can't reproduce it. So it's a lot of tribal stuff, almost unscalable stuff, I would say, was happening. And we were tied to OKR, so we had to do this consistently. So we, over a weekend, I sat down, wrote it's like, there's a way to solve these problems. We saw that there were multiple steps. We're like, let's do these things called as pipelines and so on. And we got something basic running with Airflow, was able to really with blood, sweat, and tears and man behind the curtain get something running, which is good enough, right? We were able to prove that there is this operationalization needed and a solutioning happening. But at the end of it, we talked with a bunch of, we presented it to the company in an all hands meeting, and we found that a bunch of different teams were struggling with the same stuff. And they're like, hey, why don't you platformize this? And I will use it. I'm like, this is not platformizable. This is just some hacky code that we wrote over a weekend. So that led me to write like a big paper of requirements, you would say, like about 15 pages long. I think these are the things we need. This is what it is. This is how the things are evolving. And we need this to be solved. And if you build it, I will use it. Because I didn't want to build infrastructure. I'd done a lot of infrastructure prior to that. I was like, I'm here to solve my problems. I'm going to do that. But we were 70 people, 80 people in the company, engineers. Nobody had the time to build anything. And that's what led us to like, okay, we'll take that challenge on and we'll build something. So we built the first version of Flyte, which is built on top of AWS step functions and batch and ECS and all that. And we delivered it. And in about 6 months, we had about 15 teams, critical teams using it in production. And we're like, oh, what happened here? Why did they use it? And we started talking to everybody. And that's what made me realize, like, again, it's not a point in time where we had a realization. It's like a period of experiments and different kinds of deliveries and sustained outcomes that the people received, which led us to realization that there is something more. We also got called out by different companies and we shared our learnings and, we started seeing that they were also interested in this, which basically told us that, why don't you open source it? Like, a bunch of companies told us to open source it. And that was when we were like, hey, to open source, we have to actually build the infrastructure in a open sourceable way. And we were already at a point where our Skunkworks project was not really scaling, right? So we were like, okay, we have learned a lot. Let's redo and rebuild this again from scratch, keeping one jet engine going and rebuilding another engine. That's what it was. And maybe one of the reasons why it was called Flyte. And that's what led to the creation of Flyte as we know it. And we open sourced it a couple years after, 2.5, 3 years after it was built. The prime realization why we built it is that we found like maybe 2 or 3 things. One thing was, I actually looked back and I said, why am I doing this? Why am I writing machine learning pipelines and models and so on? Yeah, when I was under ETA. And I was like, I have enough of an infrastructure background. I could be working anywhere, building infrastructure and so on, like databases. But this has a higher impact value and a higher product value that I can deliver, which made what it felt to me is that if I could be doing this, I thought that this is going to be the direction that many other people might do. And I saw many, many people within the company just building ML pipelines. So this is the direction we're going in. So this is going to be a wave. And there needs to be a solution that actually makes people like software engineers and data engineers and so on deliver AI products consistently. So that was one. So it was like a realization that there's a change happening. And the second thing was there is a change. The difference in building the way we build software and the way we build AI products was different. The entire process was different. An example of that, the way I characterize it is that a database is like a pure software product, right? You build it, Postgres is like 40 years old or 35 years old or something like that, right? It still works great. And it actually keeps on improving, like refined wine now. And the reason for that is because it was based on assumptions, and as hardware and disks and network and computers got faster, it got better. So environmental changes actually improved it weirdly. On the other hand, AI products are inverse. They get worse because of infusion. So that was the second observation, that the way we have all of this tooling is to build software products. How can you apply that to a product that's dynamic, constantly changing, evolving? You have to restart with assumptions, new assumptions often. And oftentimes a model like ChatGPT, even in production, is not going to be the best. 1 year later, it's probably the worst model till you need a new model, right? So you constantly need to reinnovate. And the third one was, it's actually the biggest problem in AI is organizational silos. People are unable to work together. Like data engineers, ML engineers, and software engineers all need to work together to deliver a product, because these are complex living products that are delivered to customers. So we said, okay, if these 3 things are coming in, there needs to be a new platform to be built. And that's how we started building machine learning platform at Lyft. And one of the core components of that was Flyte, which got open sourced.
I'd love to, so tons to unpack there. I would love to start with the Airflow problem. So, there's many orchestrators that exist. There's always kind of the another orchestrator problem to solve the other orchestrators. But obviously, I don't think that's the case here. I don't think it's the case in a lot of situations. But for people who maybe haven't hit the problem yet, or maybe are trying to diagnose what that problem looks like,
Yes.
Why is Airflow not the answer? What is Airflow missing?
It's a fantastic question. I'm actually writing a blog. Hopefully, it'll come out by the time this thing goes out, maybe in a week after that or so. It's a big blog. I can't cover everything, but I'll give you a few reasons. And some of them are, as I covered, I think if you go to the first principles, you will see that I highlighted 3 prime changes that were happening in the landscape.
Mm-hmm.
So, we can give high-level terms for them, like collaboration, AI productization, and software best practices within AI products. Like 3 different potential aspects. While if you apply that to the existing ETL landscape, that's what I put Airflow as. The way I characterize it is like ETL is essentially needed to build fact dimension tables and potentially drive an analytics dashboard. The absence of that dashboard, the failure to build one someday is not critical. It's not mission critical. Yes, it is not a great thing, but it's not mission critical. The failure to not build a model and deploy it, if that is a requirement for the end user product, is actually mission critical. It will have adverse effects. An example for this is we used to use real-time traffic analysis, which we deploy to production almost every 10 minutes. Mm-hmm. One of them fails. We don't have real-time traffic. We have, let's say there was a huge traffic spike and now there is no traffic. We have this tail model in production that's using the last 10 minutes worth of traffic information. What it's leading to is diverting all the cars in a wrong direction. So it leads to an unoptimal state. It is bad because we actually lose customers because the ETS look like 7 minutes and 8 minutes instead of 3 minutes when actually they were 3 minutes, right? So this is a huge challenge. This has a customer impact. And the moment there is a customer impact, the ground principles on which the product is built does not work. So that's one. The second one, as I said, is that this aggregation of 3 different types of people. So very research-oriented, fast-moving, experimentation-driven system. If you think about Airflow, like when we were doing it, you had to deploy. We were running one of the biggest clusters of Airflow at that time. You have to deploy and all the workers would go. You could deploy, let's say you deploy a new version of the pipeline, the existing pipeline would die because or any of the working tasks would die and then you would start a new one. This sounds like a simple problem, but this stems from a basic construct. Like an example for that was if you one of our engineers imported XGBoost, and another one wanted to use like GBM. Like GBM wasn't there at that time. I think one of the other ones, scikit-learn, maybe some version, and there was a version conflict, and all the DAGs failed. And I'm like, there is a huge conflict that's happening because of the design. It's like it's based on like the simple Pythonic import-based system. The scheduler loads everything into memory. It doesn't work. Another thing was, as we were experimenting, how do I experiment? I cannot deploy it to production. I cannot modify the existing. I need a version. I need Git-like semantics to work with it. It seems like, I will hack it on to Airflow and so on. It doesn't work. You cannot. You need the idea of portable DAGs that you can ship easily. Another example is we wanted everything to be runnable locally. We just want people to run locally. Right? You start experimenting in cloud, it's too expensive. We used to spend tens of millions of dollars on Flyte at Lyft, right? And so any dollar we could save would be effective. And there have been now many, many posts by many different users of Flyte who are showing that they are saving 50% on infrastructure costs just by using Flyte, because Flyte allows you to run everything locally. And then it ships from local to remote and it exactly works. It's pretty amazing as a power. Then we wanted things like memoization. Like, you've probably know this already. When you're experimenting, you have 15 steps, 11 steps don't change, and the 12th step changes all the time. Maybe that's the training loop, right? Or you want to change a few hyperparameters. So you want the 11 to just reuse. Now, yes, you could achieve all this by breaking apart, modify, doing. It's a pain. And one of the goals is to reduce the pain and reduce the friction. So again, we had to go to the first principles to actually understand how to do these kind of things. And it's not easy. It seems like a lot of people are tacking on caching or memorization, but memorization in languages depends on the type system and the knowledge that this data is stored in heap versus on stack. And so you can actually optimize certain things. You can't do that. How do you do that in a distributed system? So you had to really go from the ground up to build that thing correctly. Because we have seen a lot of horrendous cases where it would get it wrong and you wouldn't even know. It trained the model on the wrong data. You wouldn't even know because it used the wrong cache outputs. It's a correctness issue. And I don't think people, and I highly recommend people to please understand when you're using caching with systems that are not built with these things in mind. It is not the same as building ground up for solving a problem, right? And so many such problems. But the core context of the second part was that it is essentially a tight iteration loop in the beginning for researchers that you need to make it possible. Like literally writing code, shipping to scale should be 1 second. And then from there, instant productionization and having a stable version in production while I'm experimenting with it. This is a critical requirement. And then the final part is how do you collaborate across data engineering, ML engineering, and data scientists and software engineers? And they all have their own requirements. Some of them have different languages. Some of them have different frameworks. So all that needs to work. And so these are the reasons why we really tried out. We did not want to build infrastructure in 2016. But we just fundamentally did not see that path. We actually then went to step function saying that, hey, this is just a pure orchestrator. We found that infrastructure is a massive challenge. Like if you think about it today, if you're a data scientist researcher, you start with like, I'll use CPU. And then you're like, oh, hold on, I need a deep learning model. Let me use GPU. Hold on, I can't use V100. I want to use A100. So it's not A100. I need H100. Right? You're just scaling. Similarly, I want to use Dask or Spark or Ray for some tasks, but I don't need to use it for everything. I just want to fan out to massive number of machines to just run a batch prediction. It's crazy to me how many times people are using Union or Flyte today to run 50 to 80,000 containers in parallel. And actually the cost of running this, because we do partial state safe, is extremely low. And this is extremely, powerful semantics. And so these were built because we saw how backtesting, how evaluation, how hyperparameter tuning, how multiple parallel execution is a requirement of the system. And that's why we built Flyte.
That's awesome. That's like the most, because I feel like I ask that question a lot, like how does this compare to Airflow? Because Airflow kind of competes with everything. It's a very generic tool. I mean, it's just like at the lowest level, everything is sort of some form of orchestrator.
It's a hackable tool. To be honest, it's a great hackable tool. Like, I will take Python, hack it up, like do something. I'm like, oh, I got something running. It doesn't scale, right? If you should think about if you're building a successful organization, eventually you have to make it work consistently, right? Which is a problem.
And I think kind of what you touched on is the workflow problem, which I think a lot of people miss. I think a lot of people like to think about scaling and size of data, and obviously those have their own problems, but almost orthogonally is ML is a very iterative process. There's this experimentation step, which as software engineers, it's like not understood because there's not an equivalent step. In software engineering, you don't really, I'm going to just go down this path for a week or 2 weeks, and then if it doesn't work, I'm just going to throw it away. Like you just don't have that workflow. I like to explain it by saying it's software engineering and data science. And the science versus the engineering is really, really important because it is a completely different way of thinking.
And you're hitting it right on, like, that's what I say the difference between database and an AI product. AI product is incremental. It's not incremental. Software products are incremental. AI products are almost transformative, massive potential, but become zero at some point, and then you have to restart the process. And this is actually all executives need to understand that AI is not like one-time investment. It's never going to be. It's going to be a continual investment that you have to continuously evolve, actually more so than even software. Which is pretty interesting to me.
Yeah, it's because it's so transformative. I think also consumers' behavior and the expectations change. Like once everything is injected of GPT or LLMs, It's just what people expect is going to be dramatically different. Not dissimilar to you not having a website would be like a huge, like just like how can you not have a website? That's just an expected thing. I think the same thing is true with AI. Like soon it will, if you aren't smart, like if your product or application isn't smart, it's going to feel like, like
outdated.
You're pulling up. Yeah, exactly. It's like, oh, like I'm pulling up my old school 90s, whatever, like software thing.
The example that I think it's a great analogy, and I'm like just thought about an example of like it's like you remember those IBM terminal apps that people used to run all the time. I forget what it's called. I forgot the term. Sorry. And then you go to a web-based app, which is like fast and responsive and like easy and like globally available. It's like that. That once you go this way, you can't go back. And I think
totally.
most legacy companies need to start thinking about, and they are. I think OpenAI, whether they reach AGI or no, has done a fantastic job in the world to show a different path. So,
yeah, I totally agree, and I think unlike past kind of waves that have come through, this one is so obvious. I think that no one's kind of getting caught sleeping. At least I'm not really seeing anyone caught sleeping. I mean, the actual speed you can move and get things production ready, especially if you're an enterprise, is going to be different depending on what you're doing. There's a lot of prototypes that are getting out there. That's fine, but they're prototypes very clearly. It's quite difficult to get an actual critical path kind of LM application in because in a lot of situations, it's not well understood. So unless you frame it as this is just a prototype, it's just for fun, it doesn't really matter. It's really hard to get things through.
Oh, trust me, people don't frame it that way because you know what? The challenge over here is, again, I'm a software engineer, so I'm going to probably do this and hate like the clan is going to hate me, but I think us software engineers think that we extrapolate our past and put it in here. And we're like, this prototype worked, unit tests work. That means it's going to work, right? Let's put it in production. That's not how it works with AI. It doesn't work with AI. Actually, most often, the best performing model that I had on my test data set did not perform well in production. Across many years at Lyft, at running thousands of models in production, I can tell you that. And consistently, right? It was not the coolest model that worked the best. It was sometimes the simplest model that worked the best. It was sometimes the most complicated models that worked the best, right? And it often changed periodically. So it is a new learning that all of us has to do. An example for that was also I was talking to somebody who was like building chatbots, right? I think it's a lot of I don't want to call it chatbots, but like an LLM application. Mm-hmm. I'm like, how do you deploy new versions of this to production? They're like, yeah, we just go ahead, test it locally, and then deploy.
Yeah.
And I'm like, okay, what if it regresses? I'm like, why would it regress? We're still using OpenAI. We're still using the same database. I'm like, hold on, it doesn't work like that, right? You know? And then I told them about the idea of A/B testing. And these people did that. Right? They knew about A/B testing, but they didn't think like, why do you need A/B testing? I'm like, this is because the behavioral pattern changes. And that's a huge outcome for your customers. I think OpenAI themselves had a problem. They deployed a chat GPT or a new GPT variant, which actually, I forget what it was doing wrong. I think it got the code wrong or the tool wrong or something. And it's a massive change in behavior and it impacts everything. It actually could have a downward effect on your customer. So you have to be careful about it. And this is true with all AI products, including legacy ML products that we've been doing for 20 years now, or 15 years.
Totally. Yeah. I remember actually a few times where I would go on, there was like one time where it went viral on Twitter where it was almost like having like real hallucinations. Like it was just like kind of going off the deep end on like random questions. And it was quite entertaining. But again, if you had a critical application dependent on it, like this would be a huge deal. And I think similarly, I mean, my background is in recommender systems. So it's so funny how much like stuff that was old and obvious to me. Yeah, it's the same problem. Like, how do you evaluate a recommender system? Well, it's the same thing. It's like people are like, oh, just put a thumbs up, thumbs down, but no one clicks the when's the last time you clicked on a thumbs up, thumbs down? So you use implicit information. And so it feels like we're kind of relearning a lot of the things that we learned in recommender systems all over again.
Also, the signal dies. The signal becomes worse over a period, right? Like, it's just that. That's like, even if consistently everybody puts thumbs up, thumbs down, the signal becomes diluted over a period of time. You need new signals in AI.
Exactly. And I mean, the other thing that also applies to most AI use cases is the idea of serendipity, which some of the times you just have a specific goal, in which case it's more obvious. But a lot of the times, like, there's a difference between that technically answers my question, and whoa, like, that just changed my whole way of thinking about something, which I've had happen in ChatGPT before. Like, I asked it a question about something I'm trying to kind of wrap my head around. Like, I'm on the side that I really love physics, and sometimes I'll ask it physics questions, and it will say it in a way I'm like, oh, like, I thought I understood this thing, but now that you put it this way, it's just, this answer wasn't just good, it was just excellent. And that might have only been to me. It might have been a really bad answer for someone else. And so learning how to do that stuff is just, it's hard. And we're going to have to relearn a lot of the same things in this new environment, which is kind of, I feel like an old person saying it, because I remember when the people before me were like, like deep learning, like it's just another phase. Like, we're just doing all the same things over again. I'm curious. I mean, we've been talking about LLMs for a little bit here. I know Flyte's been releasing some workflows around LLMs, agentic workflows. I'd love to kind of get a sense of how you're thinking about the future there, with Flyte and Union specifically.
Yeah, with Flyte, we have not released any agentic workflow. There's some experiments we've done. It's actually pretty interesting. Literally, when ChatGPT came out about a year ago, I sent an internal message saying that, we have to see where this is going, because this might be the right thing to be building for. And here's like a way, right? For example, but we were like, okay, I sometimes wonder if I should have gone and done that and created a hype, but also I think it was probably too early. Sometimes there is a advantage of observing and moving correctly. Specifically because we have our market for Flyte, I think, is specifically towards single task growing to multiple tasks, to workflows, to complexity, to reducing that complexity, right? What's happening with LLMs is, and many people have come to us and they were like, hey, can we use Flyte to do these like chatbots and so on? I'm like, oh, hold on, that's not the right use case. Please don't do it. Like, again, I tell people right now, it's not the right use case because it's not designed for it, right? And the reason why it's not designed for it is the performance. It's the performance implications, nothing else. But when we build Flyte, and I want to tell people who were seeing this maybe might realize, some people who are deeply using it would realize this, is that Flyte is an implementation of a protocol, and the protocol is a way of connecting pieces. So that's one implementation of the protocol, is to actually create ephemeral infrastructure, which can be slow, but is extremely cost efficient and has this massive benefit of rapid iteration. Another implementation could be something that goes really fast. Doesn't need to state, can connect pieces yet in a logical way, because the base pieces are still right. Like, one of the things with LLMs and creating chains is that you want some semantic correctness to be associated with it, right? LLMs could dream up whatever change you want, like saying, like, go call Instacart and do this and do blah and so something, right? But how do you know it's correct, right? How do you know that the inputs that you're going to pass to this API or the tool is going to be accurate? Like, then you have to do custom coding to manage and massage. And so what if you solve this at the semantic layer and make it better? Because we've been doing this. Like, programs often do not fail because they are statically typed and checked and whatever, right? So one of the things with Flyte, you do get that. The other thing is it's shippable rapidly, so you could move things into a hosted experience to be really, really fast. Like, you could actually take a local idea and ship it to production rapidly. And because it is centralized, you could actually have cost advantages where you could run the cost of running, like, let's say 5 chatbots which are doing A, B, C, D, E tests or multi-amp bandits or whatever you want to do. You could get cost advantages for them, because that's another problem, right? People don't realize, like, AI becomes extremely expensive because of the experimentation. It's extremely expensive. This is a true problem even with LLMs, right? It's going to be like, think about if ChatGPT or OpenAI has to run 5 models always in production. It's extremely expensive. They would much rather be using the same infrastructure for one. But you have to do it just to maintain correctness and backwards compatibility, for example. And so we think this is an opportunity for us to disrupt and change. And this is where we are going because it's a natural way of thinking about the problem, about how workflows or pipelines or graphs or whatever you want to call them, chains are created and how they're semantically correct construction. And it is tunable as well as observable and yet extremely low footprint in terms of expensive for the user.
So one thing, and this will probably be our last question, that I really wanted to get your take on it. There's also, I think, there are a new set of data scientists that are kind of really just LLM scientists. Like that's all they've really used, and a lot of the focus has gone there. There's obviously the traditional machine learning that's been around. I mean, there's statisticians too, and a lot of different kind of waves of things. But specifically, my question is, how do you think ML, traditional machine learning, like what we had been doing for many, many years before GPT was released, how is that going to get disrupted? Is it going to get disrupted? Do you kind of view that these are two different things that will live together? Do you think that LLMs will kind of become the de facto thing?
Disrupted is a big word.
Yeah.
I think I actually want to maybe contrary opinion to people. I think it's more of I think the disruption that's happening is to legacy software.
Yeah.
The disruption is for software that people are now finally realizing that AI is there. We have to use it. Yeah. Which is fantastic. And so let me give you an example. I think about it as a pendulum. So the pendulum was, most people thought ML is a narrow market because it's hard, it's expensive, it's hard to productionize, a bunch of other things, right? Which is true, right? It doesn't mean it's not. So it will only be the top 500 companies in the world will probably do it, right? So the market is small, whatever. That was here, right? And then the remaining people are not going to touch it. They'll play around, do something, but it will not be as critical and important. With ChatGPT, this pendulum went to the other side. Yeah. It's like, oh, everything's going to be AI. And I'm like, okay, and doomsday and all kinds of random prophecies. And I'm like, hold on. I think if you naturally saw the progression of AI, you would have assumed this is going to happen. Now, I never thought that it will happen in 2022 or 3 or whatever, right? I thought it might take. I didn't know the timeline. Yeah. I didn't know if it will happen in my lifetime, but I knew it was going to happen. Another one is going to happen. Another one's going to happen. And eventually there will be an AGI. It's going to happen. Is it going to happen in 100 years, 200 years, 1,000 years? I don't know the answer. But if you take that as a goal, there are two things that I think about. One is a fear that are we going to enter another AI winter, which is a terrible feeling to feel because, whenever there is one success point, a lot of innovation dollars go towards it. Yep. And my feeling sometimes is, are we in a local minima? Like, have we hit that local minima with LLM, with transformers? And now it's just like, okay, let's go transformer. And maybe it's not, there is no solution over it. I don't know. I can't tell, right? But hypothetically, from the pure point of view of what a transformer does, some people are saying we'll reduce hallucinations to like almost non-existence. And I'm like, but that is a feature. How can you reduce hallucinations for something that's so creative, right? Like it's built on this idea of, by design. How do you produce? You can augment and reduce, but you're basically building a new model, right? It's this entire thing on top you're building is a bunch of models. We used to do ensemble ML techniques and like 5 different models and personalization. All of those will happen. So it's natural. with one more new way of doing, like XGBoost, like GBM, regression. Now we have a new way of doing this generative AI. And I think another one will come in, like video based. Another one will come in. And I think this is going to continue. So the disruption is going to happen for software, but I don't think the legacy stuff is going to go away. Like I've still not found a great way to solve operations problems. Or solve like simple behavioral detection, or even like vision problems. Like you have to segment the image. Like you need a model to segment the image. Now that's a deep learning model. I'm not saying no. I'm just saying that it's not a generative AI model. So
yeah, I think that's spot on. I think I've always viewed it as it's another tool. It's a very powerful tool, but it's another tool in our tool belt, and it will, like, my I guess hot take is that I think in 5 years the most common model in production will still be some form of a random forest, whether it's like GBM, XGBoost. It's still some sort of like
it's hard to beat them.
They work really well, really easy to understand, they're really cheap, and most applications today, a lot of kind of the ML you see are fraud detections. It's stuff that is so transactional and like this, as in like it's so fast and so critical to kind of have some level of understanding that an LLM is just not the right tool for it. At least I don't think so. It's just you can make it do it, but it's not the right tool for the job. And I think we're seeing that now. And I think what I'm seeing is a lot of the kind of big companies are finding ways to put these things together, their ML and their LLMs, even at the platform level. And I think that there are other approaches I'm seeing where it's just like trying to build this whole new thing and use LLMs everywhere. And then you use LLMs to evaluate LLMs and LLMs to create features that feed into other LLMs. And you start to kind of maybe oversaturate. It's just because no one's doing evaluation well, these things sound so cool and they kind of work that I think people just like want them to work. But I think we're going to get to that. In the end, even deep learning
of cards.
Yeah, it's just there was this stats. I mean, it's just in the end, you need to understand data, see what the data is doing, find the best way to put that together. And this is another tool that takes data in and generates data in a way that's unbelievably accurate compared to what we've seen before. This has been awesome. Okay. I feel like there's so much stuff I would want to keep talking to you about. So maybe I'll have to pull you back on one of these days. But I really appreciate you taking the time and answering all my questions and sharing your views and learnings with our viewers.
No, absolutely. This was fun. I think we went really on the right tangent. Like I think again, probably we look back and say like we were all stupid that maybe LLMs did everything. But who knows?
That's always a risk.
Yeah, but I do think XGBoost was a change in the way we solved the problems, and that happened. And now LLMs are doing it, and hopefully there is one more. Like I think the vision models, there's some new generative AI vision models are pretty amazing, and the video models are pretty amazing. They're going to do amazing things. We just are increasing the TAM, in my opinion, just increasing the market here. Let's do it. Like I think it's better to embrace it and let's go with it.
I agree fully. Awesome. Thanks again.
Awesome. All right. Take care, man.
You too.